Alright, welcome to the Base Layer Robotics channel. I am John Ferret and I will be your host. This is the second video of the channel, but will be the first slightly longer form video. The first one was kind of a trial run. But before we get started, I want to be very honest with you guys. I am an engineer. I'm not a content creator. This is awkward for me to even be in front of a camera to talk about what I have done. I would rather spend my time coding, machine learning, algorithm development, and my newfound hobby, robotics. So I can't promise that I'm going to have the most high quality content out there like other people will. But if you're interested in, watching an engineer do some engineering stuff and talk about engineering related stuff, then follow the channel. Give me some props, like it, give me a comment. Let's see if there's anything interesting for you guys. So, all right. What I've been working on lately is a balance bot project. Basically a two-wheeled balance bot. I took a 25-year-old wine box and I also took a child's hovercraft. I bought a $90 child's hovercraft, Chinese child's hovercraft off Walmart. And I repurposed the wheels, the axle, the battery, and one of the motherboards to use to recharge the battery. And I basically configured that onto a wine box. We'll bring up the bot in a few minutes and I'll show you that. And I wanted to put a neural network controller and control the thing with neural networks. At the same time I did this, I've also been building a platform called Dojo. Not to be confused with Elon Musk's Dojo supercomputer at Tesla. I'm very aware of the same name. But Dojo just means place to train. So I've been building my own ML platform at the same time. It's called Dojo. It's currently not available. It will be. It's not available right now because it's serving as my research platform too. And I have a lot of research stuff and notes and stuff intermixed in the code. We're not even going to get into Dojo in this video today. There'll be plenty of time for that in the future. I think if you guys are into ML, I think I've got some stuff going on there that you will like. But today I mostly just want to give a status update on what's going on with the balance bot and where I'm headed with it and why I think it might be interesting for you guys to follow along. So, to actually build a basic balance bot and get it to balance with a neural network, it's not that complicated. It's the gist of it is you're sending a V forward or a V left and a V right command in, and the neural network policy is outputting a V left, V right, sending it to the wheels. There's a few more steps in there, but that is the essence of what's going on. The bot has to learn how to balance and maintain balance while it gets a command to move. Most people, when they build a basic PID balance bot, they just get it to balance. They can push it around and it bounces back. I'm trying to make a balance bot that I can eventually put a perception layer on, and it can drive around my house like a sentry bot or a go get me a beer bot. I don't really know yet, but I want to put a perception layer on it and give the bot, the ability to move freely through the house as a two-wheel balance bot. So the most important part is to get the control layer rock solid. The way I'm trying to do this is I want the perception layer to not think about control. It's going to say, perception is going to identify a doorway that it goes to, and it's going to say, go forward 3 feet. So it's going to issue the command forward. The controller is going to take the command, and it's going to start, it already knows how to execute forward, it's going to go forward. Or it's going to say turn left, turn right, tank left, tank right, something like that. And the control layer of the robot will know how to do that. So the robot, as I'm currently devising it, will be a perception layer and a control layer. And the perception layer is just going to issue commands to the control layer executes the command. So that ought to be pretty clear why the control layer has to be rock solid, right? That, and plus if I'm going to mount an expensive stereo camera on top of a balance bot, I don't really want this thing just smacking it on the ground and breaking it first right out, right? So the challenge is actually not getting the thing to balance. The hardest challenge by far is actually getting this thing to track forward correctly or track backward correctly, or even have equal tank turns, on both sides and things like that. And so what I'm going to do today is actually fire up the bot, get it in the living room, show you the teleops control that I have, and then kind of walk you through how I'm testing it, show you the current limitations, and then set you up for the next video where I talk about how I'm actually trying to build the balance controller. I'll give you a little teaser. It's using residual neural networks and distilling it back down to a base policy. All right, let's get the balance bot out and let's go look at some control behavior. Got this wired up. Stick this out here so you guys can see it. This is just a little phone app for teleoperations. Tank control left, tank control right. So forward left, forward back, left right, forward back. And then the center one is just for me to test straightness, which is what we're going to test right now. That's pretty much perfect.
forward tracking behavior. Good forward turn. Good forward track. Backwards has got a little drift to it for sure. Let's bump up the power a little bit. That's a 2. Let's go to 5. Let's see what we get. Still very good on forward. Tank is pretty smooth. All right, hitting our back. Actually pretty good. It always seems to get unstable on that particular tank turn. All right, so like, boop. Handles the bumps really well. Like, this thing's pretty solid, man. So the pivot turn in the reverse. Goes once it gets going. Pivot turn forward the other direction, and pivot turn reverse with that same direction. Oh, we're gonna have to, let's get out here where we can do that. There we go. Oh, that one's high power. That's super high power pivot turn, man. Let's get out where we can actually control it a little bit. Boop. This thing is pretty high performance at this point.
All right, so as you can see, the control layer is coming in pretty good. It's obviously the next day, that's why I have a different shirt on. Like I said, I'm not a great content creator. So anyway, gonna kind of set the stage for the next video. We'll talk about how I'm actually building the control layer, neural networks and stuff. It's basically, if you want to front run it, is using residual heads to train in behavior and then distilling those back into the base policy. This is all a learning process for me too. I am not going to pretend that I have all the answers. If you want to watch me learn and grow in public, then what do they say? Like, subscribe, and hit the bell button, and I'll see you guys next time around. Have a good one.